How to troubleshoot and fix bugs in complex legacy code. Have you ever faced the daunting task of troubleshooting and fixing bugs in complex legacy code? It can feel overwhelming, but with a structured approach, you can tackle it effectively. Let's break down the steps to make this process easier. First, start by isolating the problem within the legacy code. This means breaking the code into smaller, manageable segments. By doing this, you can pinpoint the exact source of the bug without feeling overwhelmed by the entire codebase. This method helps clarify where things might be going wrong. Using version control systems, such as Git, is essential. These systems allow you to track changes and revert to stable states if necessary. This way, if a change introduces a new bug, you can easily go back to a previous version that worked. Next, utilize debugging tools available in your integrated development environment. Setting breakpoints allows you to pause the execution of the code at specific points. This lets you inspect variables and the flow of the program, which is vital for understanding how the legacy code behaves during runtime. Step through the code carefully to see where it deviates from what you expect. Writing comprehensive unit tests is another important step. Legacy code often lacks tests, so creating characterization tests that capture the current behavior, even if it is not perfect, helps ensure that future changes do not introduce new errors. These tests also provide confidence when you decide to refactor the code. Speaking of refactoring, this is a key part of improving code readability and maintainability. Take the time to clean up duplicated code, renames and clear variables, and extract common logic into reusable functions. This not only reduces complexity but also makes it easier to spot and fix bugs. Consider breaking the legacy code into smaller modules or components. Modularizing the codebase allows you to isolate dependencies and fix issues progressively. This approach improves both debugging and future development. Static analysis tools can also be beneficial. These tools automatically detect potential bugs, code smells, and security issues. They can scan large code bases quickly and highlight areas that need attention, saving you time and effort. Maintaining documentation is crucial as well. Documentation tools that integrate with your workflow can help generate and keep up-to-date documentation. This makes it easier to understand the logic and dependencies within the legacy code. Some tools even offer interactive tutorials or assistance for navigating complex systems. Lastly, involving a technical lead or an experienced developer can provide guidance during the debugging and refactoring process. Their experience can help prioritize fixes and ensure that best practices are followed throughout. In summary, the workflow for troubleshooting and fixing bugs in complex legacy code involves isolating the problem, utilizing debugging tools, writing tests, refactoring for clarity, modularizing the code, employing static analysis, maintaining documentation, and seeking expert guidance. By following these steps, you can effectively master the art of debugging and fix programming bugs, even in challenging legacy systems.